Welcome back to the YP7 channel. Have you ever looked up into the sky and noticed a flock of birds soaring through the sky? Have you ever thought about putting up artificial wings so that you can fly with them? It turns out you can't. Even with the most advanced technique, you just can't flap your arms and fly. Isn't it weird that birds can fly but we can't? Well, there's a perfectly reasonable explanation for this. Simply flying defies the laws of physics as humans, and our body weight just can't be lifted. Humans are mammals, which means we are warm-blooded vertebrates that have hair or fur, which serves the function of maintaining body temperature, protecting our skin, and providing camouflage to hide from predators. However, birds are covered with feathers instead, and that provides an alternative function: flying. Feathers consist of a central shaft with serial paired branches, forming a flattened, usually curved surface. There are 3 types of feathers: flight feathers, contour feathers, and down feathers. Today we will focus on flight feathers. Those feathers are located on the wings and tails of birds and play a vital role in flying. There are 3 types of feathers on the wings: primary, secondary, and tertiary. Primary feathers are located at the outer part of the wings and are the largest flight feathers that propel the bird through the air. Secondary feathers run along the arm of the wings, which lift the birds in the air. These 2 types are extremely important because birds cannot fly without them. Tertiary feathers are the short, innermost feathers on the rear edge of a wing, close to the body of the bird. They are not as important for flight as the primary and secondary feathers. Feathers at the tail of a bird is also important as they help control the flying direction and maintain stability. When a bird flaps its wings, these feathers cooperate together to create a strong downward force that upwards and propels the bird against gravity. However, having a wing is simply not enough to help a bird fly. As we know, our bones are made up of marrow, tissue, and calcium, which make up around 14% of our weight. In comparison, birds have hollow bones, which only make up 5% of their total mass. The truth is that their bones aren't completely hollow like straws are, but are actually pneumatized, which means there are sacs of air that provide oxygen to their blood. The bones are extremely dense, making it difficult to break and actually stronger than most animals. The primary reason as to why we can't fly is that it's impossible to create a lift strong enough to withstand the force of gravity. Birds also have very strong muscles, but the most important part is their pectorals and the supracoracoideus muscle. The very big pectoralis muscle is what powers flight, which ultimately enables flapping, and the supracoracoideus is much smaller but assists as an elevator during upstroke, which is used to slow down and moderate speed. Such strong muscles require a board attachment on the bone, and this is where the keels come into play. The keel is an extension of the breastbone, which is perpendicular to their ribs and extends outwards. I am sure you have seen a particularly large breastbone when you are having chicken for dinner with your family. This bone anchors one edge of the muscle to allow the contraction of muscles while flapping. Both the strong muscles and keels are key to fly for a bird, and a bird cannot fly without any one of them. Are you a fan of freestyle swimming? Some people hate it, especially the driven shoulder freestyle. Just think about this: you have to rotate your arms on the surface of the water frequently just to create propulsion forward. Doesn't that seem exhausting and seems to take up lots of energy? Similarly, flying burns up energy crazily, so a large amount of energy is required. In the body, cellular respiration provides the energy needed for regular activity, and oxygen is required to participate in this respiration process. Therefore, it means that birds would have to increase the efficiency of breathing so that they can acquire enough oxygen for the body. In order to do that, birds have evolved lungs to contain special air sacs. They help the air flow in and out in only one direction so that no stale air gets trapped in the lungs. Besides, they have rather thin capillaries with more uniform walls in their lungs, which significantly increases their rate of air exchange. All of these contribute to higher efficiency of oxygen intake. For birds, there are many other ways to reduce body weight, such as laying eggs and pooping frequently. Unlike live birth that mammals go through, birds lay eggs and wait for them to hatch on their own. One advantage of laying eggs is that it helps reduce weight because carrying a baby inside them adds too much burden to flying. Also, birds poop so much because their metabolic rate is very fast, allowing them to digest more food. Remember, flying is an extremely energy-consuming activity, so they would have to constantly eat food to make up for that loss. In order to absorb nutrients as quickly as possible, those foods are generally not fully digestive, even at the end of their digestion. Of course, poop has weight, right? If there's too much poop in their tiny bodies, they will not be able to fly since it weighs them down. Remember, flying is all about lightweight. This is why there's always this unlucky guy that gets hit by it. Realistically, it is mathematically and physically impossible for humans to be able to fly. If we were to, hypothetically, be able to fly, however, for example, in a different universe, we'd need to be much, much smaller than we are now. Our wingspan may have to be up to 7 meters long. Even if we can make it, these wings would be too heavy to function. But let's use some imagination. What will it take if we wanted to fly with wings? First, our arms would have to be very, very long and strong to flap. But what's the use for our legs? Big legs would be subjected to strong air resistance while flying as well, so we would need small, thin legs like birds have. Maybe we could just cut off part of our legs, make it short and lighter. What else do we need to be able to fly? Super, super strong muscles to help flap the wings. But where should the muscles attach? We would also need to have a bone in our chest that holds the muscle firmly, which acts like a keel. Besides, our bones are too heavy. Perhaps we can replace them with hollow, air-filled bones like the ones in birds. Also, our lungs are too weak if we want to rely on them while flying, so what should we do? Perhaps we could replace our lungs with artificial lungs like the ones in birds, so that we have higher efficiency in getting more oxygen. In addition, our digestive systems are way too long. Foods go into our mouth and then go through the esophagus, stomach, small intestine, and large intestine, and finally goes out. It takes way too much time to generate energy. So perhaps we can shorten the length of our intestine, so poops go out faster. We won't need teeth either. They add extra weight, so from now on, we'll just swallow the food. And we can take out the bladder. We don't need extra space to store urine, we just pee right away. And we certainly don't need a rectum. We just poop out in the sky because we don't need anything to add weight. And take out the womb? Carrying a baby inside of us is too heavy. So perhaps a test tube baby that breathes inside an artificial breathing machine? Remember, these things above are random fancy thoughts, more of an imagination. We don't know whether they are theoretically feasible, but it's interesting to think about how much it would cost to just fly like a bird. It is fun, however, to imagine what life would be like if we were able to fly. Until then, all we can do is observe those who can and appreciate their beauty. Subscribe to our channel, Youth Pioneers in STEM, to watch more interesting videos in the future.